So now we want to solve a fractional inequality here. We want to find out when the quantity 1 over 3 minus x is strictly less than 1. Here is the graph of 1 over 3 minus x. And notice that that has a vertical asymptote here at 3, which is a 0 for the denominator. And then here's the line y equal 1. And we want to know, well, when is the graph here, the black line, below the dotted line? So it should be, for these x values, looks like less than 2, and then everything greater than 3. So, but we want to be able to confirm that algebraically. Okay, you can't go by a graph. A graph is an estimate, usually. So first thing that we want to do, like we did before, is we want to find out where these two quantities are equal. So that'll be where the difference is 0, and that'll be the cutoff points for this graph being above or below the line y equal 1. So we're going to take and we're going to set the 1 over 3 minus x equal to 1. And so bring that 1 over as a negative. 1 over 3 minus x minus 1 is equal to 0. So you've got to get everything in relation to 0, because positive negatives in relation to 0, not 1. And so now we want to write that 1 as 3 minus x over 3 minus x, get a common denominator. And then let's see here. In the numerator, we'll subtract, so 1 minus parentheses 3 minus x, all over our LCD of 3 minus x. We're setting that equal 0. And then if we subtract here, 1 minus 3 is negative 2, and negative of negative x is positive x. So this is x minus 2 over 3 minus x, and equals 0. So then that means that the places where this is equal to 0 is when the numerator equals 0. So x minus 2 equals 0, which means x equals 2. So that's going to be one cutoff for our sign analysis. But also where the bottom is equal to 0. That asymptote is a place where this graph can switch from positive to negative or negative to positive. So we also set the bottom equals 0. So 3 minus x equals 0. Bring the x over as a positive. 3 equals x. So we got two cutoffs for our sign analysis here. So here's our x number line. We've got 2 and 3 are cutoffs here. And then we're going to analyze numerator and denominator signs in our fraction, and that'll tell us when this is less than or greater than 1. So we'll have a test value here. Our factors are going to be x minus 2, the numerator, and the 3 minus x in the denominator. And then below the number line, we'll put the sign of the quotient, x minus 2 over 3 minus x. So test numbers, let's test 0, 2.5, and 4. Let's pick one number in each region. So if we plug a 0 in here, 0 minus 2, that's negative. Plug the 2.5 in, 2.5 minus 2, that's positive. Plug the 4 in for x, 4 minus 2 is positive. Do the same in 3 minus x. So plug our 0 in, 3 minus 0 is 3, that's positive. 2.5 in here for x. 3 minus 2.5 is positive. Plug a 4 in here for x. 3 minus 4, negative. Negative divided by positive is negative. Two positives divided are positive. And positive divided by negative is negative. So we want to know when is 1 over 3 minus x strictly less than 1? Well, that's going to be the same as finding when x minus 2 over 3 minus x is strictly less than 0. So the less than sign here is the same thing here. So we want to keep these two regions here. And this is a strict less than, so we're not going to include 2 and 3. So our solution set here is going to be negative infinity up to 2. So that's this region of the number line. And then 3 to infinity over here. So we'll union those. Union 3 to infinity. So that's where the quotient is negative, but those are also the values where the function is below y equal 1. So over here, that function is below y equal 1, and then over here, function's below y equal 1. So that's how you solve fractional inequalities.